Look to the middle of the frame. Hanging by a thread, that's a fruit fly. It's a common household nuisance, and the thread it's hanging on was put there by the cellar spider you see approaching from the left. It's one of the most common household predators on Earth. Now, I don't usually work with spiders, and there hasn't been a spider video on this channel yet. But recently, we've been capturing some interesting and dramatic high-speed footage, like what you see now, of these spiders in action. And while I don't know much about spiders, what I've seen in this footage is teaching me a lot and kind of blowing my mind about what these spiders are and what they can do. Okay, before we dive into that footage, let me show you just how common these spiders are. The closest population of them that I have access to is actually 5 floors below this lab in the museum's underground parking garage. In the garage, they've made nearly every pipe and light fixture the home base for their cobwebs. This cellar spider, Pholcus phalangioides, is sometimes also called a house spider or daddy long-legged spider, and is thought to be a cave-dwelling species. And now they spread all across the globe by living in human-built cave-like environments. So after finding them, to start filming and working with them, a student Elias and I brought them into the lab and set them up in a small box where they could construct their webs and we could offer them a steady supply of fruit flies as prey. We quickly figured out that we needed to film them up close and in slow motion if we wanted to see anything in detail about how prey capture and silk deployment works. In this clip, you're seeing what wrapping an insect in webbing looks like in real time. It's a flurry of blurred motion that transforms a snagged fly into a tightly wrapped and cocooned prey item in a matter of seconds. Here's what the end result looks like for that fly. I'm impressed by how thorough of a wrapping job they do. The entirety of the fly's body is wrapped in more or less an even coating of webbing to where no part of the body is sticking out and able to move freely. So now I want to show you how those spiders do that in up-close detail. All this footage is new ground for me. And what you'll see next are my favorite sequences that reveal how these spiders capture prey. In this clip, you're seeing the spider do its first approach to its prey. Cellar spiders produce different types of silk, so the fly here could either be tangled or snagged or glued to a sticky bit of web. With its front leg, the first thing the spider does is grab the thread that's attached to the fly and hold it in position. And then, instead of biting, it attacks the fly with silk. The spider's long legs keep the prey item at a distance while it wraps it up both to restrain it and further secure it to the web. Now the part that I was really impressed by was seeing how the cellar spider deploys its silk. It uses its hind legs to grab and pull the threads out of the spinnerets. Now the silk is microscopically thin, which made it hard to see and catch on video, but every time it catches the light in this shot, you can see how each pull is composed of multiple strands. The back legs alternate left, right, to pull the silk and place it around the prey. In this sequence, which I filmed at 1,000 frames per second, the spider is averaging 8 silk pulls every second. Next, I wanted to see how the legs were handling the silk and putting it around the prey, so I got a series of super up-close shots to try to see just that. What these clips show is that the spider hooks a whole sheet of webbing across the length of the last segment of its leg. With one leg, the spider drapes these threads on top of the prey item, while the other hind leg below grabs the threads and pulls them up to the other side. The part of the hind leg that's handling the silk is the last segment, called the tarsus. Here's what the hind tarsus looks like up close. It's covered in comb-like hairs and ends in a longer tarsal claw. They use that tarsal claw, which is on the end of each of their legs, to grab and hang on to their web. The tarsal claw doesn't seem to be what's used to pull out the silk threads. Instead, the comb-like hairs that line the rest of the tarsus hook onto the silk threads when they're pulled up, and also release the threads when the legs are pulled back down. These silk-wrapping threads are sticking to each other at least partially due to a spider-produced glue, as evidenced recently when researchers imaged these prey wraps and saw globs of glue between the tangled mass of fibers. After the prey item is wrapped, the spider then goes in for venom injection, which you can see happening here. Feeding happens after this, only after the prey has been secured in a silk wrap and incapacitated through a venomous bite. Now this is all just one way these particular spiders catch prey. They also lay sticky lines of silk down to the substrate called gumfoot lines to capture things moving around on the ground, and I've also read that they can leave their webs to hunt, sometimes targeting other spiders. Of course, there's a lot more to their biology and behavior than what I've been able to capture and show in this video. But even with these bits of footage, I think my perspective and appreciation for these spiders has changed, and I hope yours has too. Thanks for watching.